Hello and welcome to Dev About. My name is Darren, and in this video we'll be looking at value types and reference types. Let's begin with a short introduction covering why we need value types and reference types in the first place. .NET applications run within an environment called the Common Language Runtime, also called the CLR or sometimes just referred to as the runtime. Among other features, the CLR manages the memory usage of .NET applications. In our applications, when we use an int or a string or any other type, it is the CLR which manages the memory usage required by these types. In C# there are many types, and these types have different uses and can be quite different to each other. For example, a bool is less complex than a class, as a bool performs a different function to a class. The .NET types are so different that if the CLR managed them all in the same way, then the CLR would not be performant or memory efficient. Therefore, the .NET types are divided into two categories, known as value types and reference types. The CLR treats these categories differently with regards to memory management, so that it can be performant and memory efficient. As value types and reference types are managed differently, they exhibit different characteristics at runtime. In this video, we're going to cover some of the key observable differences between value types and reference types. In this small example, we have a class at the top called person, and it has one variable which is declared as public int age. Below is the program, where we create an instance of person and assign it to a variable called customer. We then create a second variable called employee, and we assign the value of this to the previous variable customer. So we make employee equal to customer. After that, we set the customer's age to 20, and then we use employee.age to set the employee's age to 30. And then we use console.writeLine to print out the customer's age and the employee's age. Now the big question is, what do we expect to see here? Will we see the customer have an age of 20 and the employee have an age of 30, or will something else happen? There's one way to find out, and that's by running it. So here we see both the customer is 30 and the employee is 30, which might seem a bit peculiar because we set the customer's age to 20 and the employee's age to 30. I'm going to make a small adjustment here. Let's move the console.writelines above the line where we set the employee age. And I'll add another line where we can mark the area where we are changing the employee's age. And let's run this now and see what happens. So we see initially the customer's age was 20 and the employee's age was 20, which is what we expect. And then we change the employee's age, and for some reason this also changes the customer's age. It's as if there is some kind of link between these two, where when we change the one variable, it changes the other. Let's contrast this behavior with a second example. In this example, we use booleans instead of classes. On line 9, we create a variable called sweet and set it to true. On line 10, we assign sweet to a new variable called sour. At this stage, we assume both sweet and sour are true. Next, we change the value of sour to false. Then we print out both values. Let's run it and see the results. In this case, sweet was true and sour was false. It seems that changing the value of sour had no impact on the sweet variable. This is different to the previous example, where changing the value of one variable seemed to have an impact on the other. The reason for this difference is due to the fact that a boolean is a value type, while a class is a reference type. Let's go through these examples in detail and build up a logical model of the way memory is being managed. We begin by looking at a single line from each of these examples. In this example, we are dealing with booleans, which are value types. Here we create or declare a new variable called sweet. When this line executes, the runtime will allocate system memory to store this variable. This in-memory structure will have a name and a data portion. In this case, the name is sweet, but what is the value of the data portion? In a value type, the data portion holds the value of the variable. In this case, we are setting sweet to true, therefore the value of the data portion will be true. Let's turn our attention to the example below, which is using a class and therefore it is a reference type. Looking to the right of the equals, we see new person. This line creates a new object. This means that the runtime will create and store this object in memory. This object is an instance of the person type. It represents a single person in this program. On the left of the equal sign, we declare a new variable called customer. Once again, the runtime allocates the required memory space to store the name and data portion for this variable. The name is customer, and yet again, the data portion is the interesting part. In a reference type, the data portion does not contain a value in the same way that a value type does. The data portion of a reference type contains a reference. This reference is the memory address of an object. In this case, we are assigning the person object to the customer variable. Therefore, the runtime will set this reference to the newly created person object. Storing a reference instead of a value is the big difference between value types and reference types. In a value type, the data portion is the actual value of the variable, while in a reference type, the data portion contains a reference. Going back to the value type example on the top, we can expand on it so that we assign sweet to a new variable called sour. At this stage, the runtime uses the sweet variable and makes a copy of the value of its data portion. In this case, it takes a copy of true. It then assigns this copy to the data portion of the sour variable. We end up with two separate, independent variables. They have the same value, but they are independent. Now, when we change the value of sour, it has no impact on the sweet variable, which is why we see two different values being printed when we display these variables. Now let's compare this to the example using a reference type. Here we create a new variable called employee and assign customer to it. To get the value of the employee data portion, the runtime will go to the customer variable and make a copy of the data portion. The key thing to remember here is that the data portion of customer is a reference. Therefore, the employee gets a copy of this reference. This results in two variables referencing the same underlying object. When we assign a value to the customer.age, it affects the underlying object. The same is true for when we use employee.age equals 30. It's affecting the same shared underlying object. Therefore, we get the same values when displaying the customer's age or the employee's age, because when we read from these variables, it's going to the same underlying object, which contains the actual values. One of the reasons it can be a bit difficult to get the concept of reference types is because of the way developers speak about variables. Not all of the language developers use suggests this object reference. The way developers speak about variables can hide the underlying mechanisms. For example, we might say the customer has an age of 30, or the shopping cart is empty. While this isn't necessarily wrong, it would be technically more correct to say the customer variable references an object with an age of 30. Or instead of saying the shopping cart is empty, we could say the shopping cart references an object which is empty. Developers speak with this sort of shorthand for brevity and convenience, but when a developer talks to other developers in this way, there is a shared implicit understanding that they are referring to the underlying object. Not only is this reference implied when speaking about code, it is also implicit in the code itself. In order to change the customer's age, we simply type customer.age equals 30. We don't say customer.reference.age equals 30, which would be an explicit reference to the data portion. We also don't say customer.data.age equals 30 or customer.value.age equals 30. No, we simply say customer.age equals 30. The reference is implied. This is why it looks like the variable customer is a person when it is not. The variable is merely a way to implicitly access the underlying object through a reference. In this last example, we see proof of this reference behavior. Here we have a class called dessert. The dessert class has one field on it called calories. On line 14, we assign chocolate cake to milk tart. From this point on, both of these variables have the same underlying object. On line 16, we set the calories of milk tart to 250. Now we run it, and as expected, we see that these two variables have the same calories in the console output. Now let's change dessert to a struct. A struct is a value type, and given what we have learnt about value types, the two variables should display different amounts. Let's run this. There we can see that the changes to the milk tart variable have not affected the chocolate cake variable. There you have it. The proof is in the pudding.